had in that panel discussion, because it was left unsaid, but.
It was mentioned, Alistair talked about that in one of these things.
Okay, good.
When they asked him about the prioritization of the download, is that this is the president?
Right.
So
Okay,
I
it
know
was
I
covered.
heard it.
Good, good.
So,
Yeah.
Just so you guys know, we are on air now, but we have 0 viewers.
Okay. Alrighty.
but, yeah, there's been so many hours of talking about it.
Yeah. I think that's when you really know you made it, is when you're next meeting.
I like that they have a place where they're putting all the people who are still are here about Pluto's planet status. Yeah, that's really like that. I know a lot of my students are still passionately arguing in favor.
All of your students?
High school.
High school, okay.
Yeah.
They want it to be a planet?
They want to do.
A lot of people want it to be a planet.
I like them.
Yes, right. Brain is very clear.
Alyssa says, you mean the classroom part of the K Center? That's not where we are.
No,
We're,
tell her to ask at the media desk, where the Google Hangout is, and Kathy, they probably might know that I went with you guys, you know. But it's at the, ask at the media desk. Cause she won't know where the library is until somebody walks her over. In fact, I can go ask the, intern Marissa.
yes, yes.
So tell her to just go by the media desk and I'll send Marissa.
Until 6.
All right. I think. Oh, hello, NIBR. We're going to be starting in a few minutes here. We are just collecting our people. Yes. What is it meant? Present to everybody. All right. Hello, EAPS. This is Amanda Bosch. We are broadcasting from the Applied Physics Lab at Johns Hopkins University in Maryland from the New Horizons flyby of Pluto. And our apologies, we lost a couple people, so we're gonna get some people back here and we'll be starting in just a second. I was expecting that we would have some feedback, but I think at this point all I can see is that we have some people signed on. If you have any questions for us, please submit a question. There seems to be a method for doing that, and we can try to answer some questions after we just go over some basics of the Pluto flyby. We'll be starting in just a minute or two. All right. Let's see if we can do this. Okay. So hi, we're here at Johns Hopkins in a basement room at somewhere. They found for us so we can do this Google Hangout with you. So we have been here yesterday and today, and we've been, listening to all of the press conferences and talking with the scientists on board New Horizons. And so we're going to just talk a little bit about some of the things that we have seen and heard during this really historic flyby of Pluto by the New Horizons spacecraft. So as you know, this has been a long time in coming. It's many years since the spacecraft was launched, and it underwent its close passage to Pluto this morning at a little bit after 7 a.m., right? Yeah, 7:40, I think. 7:42, to be exact. And so at this point, what we're still doing is we're waiting to hear back from the spacecraft, because what they did was, as the spacecraft was approaching Pluto, they actually were concentrating all of their energies, all of the spacecraft energies, on actually looking at Pluto and not talking to the Earth and sending back any data. So yesterday was the last little bit of data that was sent back, and the team got onto it and processed it, and that was posted actually today. It was released as a press release just this afternoon, and we'll talk about a little bit about that latest one a little bit later. But since then, the spacecraft has been really just concentrating on looking at Pluto and taking as much data as it could during the flyby portion of the event, because obviously that is when the spacecraft is closest to Pluto, and so you have the highest spatial resolution there. So if you want to do things like imaging, and which we of course do, and doing spectroscopy and doing magnetic fields measurements and dust counters, really all of that has to happen in the little bit of time just around the flyby. So it was always planned that the spacecraft would not spend any of that time talking to the Earth and relaying images or any kind of results, but would in fact just fly by the Pluto system, take all that data, and then tonight we expect to hear the "I'm alive" signal, which is basically the spacecraft turning around and for the first time since before the flyby, talking to the Earth and saying, hey, I made it through, I'm still alive. And then it will start to send back a little bit of data, and then continue taking some more observations and continue sending data over the next 16 months. And so what the team has gotten back so far has been really compressed images Mostly the Lori images, which is the single color, just the black and white images. A little bit of color images too, which we'll talk about. But at this point, they have all been the compressed versions so that you can get them back quickly. And then again, over the next 16 months, then we will be seeing the full lossless data as well as all of the supporting data. So it's been very interesting so far because people are showing images and speculating wildly on what may or may not be happening in the images. It's been very, very exciting. And we actually had one of the mission scientists say, have a great quote this afternoon. He was talking about one of the images, and he said, well, that is one theory. I just made it up, so it's probably wrong. So this is really how this whole thing has been going. So very, very exciting. So I don't know if you want to give some of your impressions. We have several EAPS people here. So This is Dr. Michael Person.
Hi, I'm Mike Person, also from EAPS. I spend most of my time studying Pluto's atmosphere, and I think one of the early results, we're still waiting for the main results from the spacecraft to be sent down to Earth, but one of the early results that I find most interesting is one of the most basic. When you study Pluto's atmosphere, as I do, with stellar occultations, you watch the light refracted by the star's atmosphere, or you watch the starlight refracted by the planet's atmosphere as the star goes behind the planet. And you can follow the atmosphere down to a certain level, but then the starlight goes away and you can't see anything below that level. So we haven't known for all these years what's below that level. Is it another 20, 40, 60, 80 kilometers worth of atmosphere? But now with the initial images, and we can put a high resolution camera pointing at the planet, we can see that we have a radius for Pluto for the first time. We've never actually known how large it is. And it's been released, they have measurements at 1185, what's the number?
1180. Yeah,
1180.
1185.
Okay. 1185, which is higher than some previous measurements, but in line with others. But most importantly for me, it gives us a base where we can put the bottom of the atmosphere and know that from there on, there's just rock or ice or whatever is below that, but our atmospheric models are now constrained for the first time since we started making them. Did you want to say something, Kathy? This is Kathy Olkin from the New Horizons team.
Yeah, so I'm happy you're talking about the radius of Pluto.
Yeah.
And so we are getting that from looking at how many pixels across Pluto there are, and I think we'll have revised estimates even in the future where the error bar will get smaller as we get more resolution. So
as the camera gets closer and closer to the planet, we get a finer and finer resolution of the edge.
That's right.
Yeah.
Do you know what the error bar is now?
The error bar I had heard before was plus or minus 10.
10, okay.
And so I expect it'll go down.
Yeah. Excellent. So
we have some other guests from EAPS here. You want to come forward? Here we have Professor Binzel.
Hey, who's chatting back at EAPS? Who's on the Hangout?
We have a number of watchers, but we don't seem to get any feedback from them.
Okay,
So
well, hi, watchers. Thanks for coming, tuning in. We've had a great day. It's been great to finally get to Pluto after an incredibly long 9 years. And Pluto's knocked our socks off. We had a lot of ideas what Pluto might be like. Triton, I think nominally we would have been thinking that, if we came to Pluto and it looks like Triton, we kind of go, okay, now we understand these 2,000 kilometer sized bodies in the outer solar system. And boy, there's just almost nothing like Triton about this at the big, broad scale. So it's great. I was just thinking as I was walking over here, it's like, how in the heck are we going to explain this? I mean, this is so bizarre that we got our work cut out for us just trying to explain how do you get what would seem likely as a cold, barren, inactive, icy body to get all that diversity and the boundaries between the different regions we see on Pluto. And how do you get those sharp boundaries between bright regions and dark regions, cratered regions, uncratered regions, right next to each other is just totally baffling from a planetary science point of view. So, what a great day! It's unloaded a huge number of mysteries on us, and I've done a lot of different interviews, and I've tried to emphasize to each one of those that we hope that this is like the Apollo moment, or an Apollo moment for this generation. who didn't experience the time of Apollo and what that excitement was like. This is what it was like, and we hope it just grabs this next generation in a way that maybe other things haven't. All right, so let's see, are there any questions that have come in? Anything that we should deal with? I'll let the technology experts address these.
Do you know of any non-sphericity of Pluto or Charon's shape?
Oh, thank you. So the numbers we have, which are down in the 5 to 10 kilometer error bars, are fractions of a pixel, and I think the last images we had were, 4. What was that
The
last?
last image was 4 kilometers
4
per
kilometers
pixel.
per pixel, and I don't think anyone's done any fit to these yet. Or
Yeah.
do we have the numbers?
No, we don't have a new
Kathy has
radius.
it on top of it.
We don't have a new radius based on the data that just came out this morning. The pixel scale is 4 kilometers per pixel on that data, and so I think we'll be able to get an improved estimate. And that's a great image for doing this measurement with, because it's when Pluto is filling the field of view with. We have to have some deadband or margin on the side, because there's uncertainties in where the camera points, but so that's our large image of Pluto filling the field, which will be excellent to do the radius calculation on.
I think something great for this group's point of view is on the team, as we're trying to do these limb fittings and solve for the diameter of Pluto, we're using the same techniques on Charon, and we're using the occultation numbers for Charon as the gold standard.
That's right.
In other words, if your model and your fits and your techniques doesn't give you the number that the occultations tell you, then you're obviously doing it wrong. So it's really great. It's just this great tie-in to the occultation data that you might not have thought about, but you guys have established the gold standard for Charon, and you're driving the Pluto people. So, but it's a great science question because of course that gets us to the geophysics.
Is there any information we can gain from this flyby that might help us further our understanding of the planetary science of Earth?
Whoa, well, I'll take one crack at it.
Okay.
And you can take another. The basic constituents, most of the air in this room is nitrogen. And on Pluto, we're at a temperature where nitrogen is in this balance between being frozen and being in the atmosphere. So it's basically seeing the natural environment of a key component in the Earth's atmosphere in a completely different physical realm. So to the extent we try to understand how the Earth works, here we're seeing this basic constituent of Earth and Earth's atmosphere in a completely different way. There's ways about molecules are escaping from Pluto in a way that's really hard to measure from the Earth. Just the basic chemistry, the idea that the Kuiper Belt and Pluto are frozen time capsules from the original chemistry of the solar system in a way that geologic processes on Earth have erased all that. So those are some of the ties. You got any others, Kathy?
The only other one I can think of is the formation mechanism of the Earth's moon and Pluto's moon, Charon. They were both believed to be formed by giant impact. And a lot of times what we do in planetary science is comparative planetology. And there's not a lot of examples where we think things were formed by giant impacts. And so it'll be great to learn more about the Pluto system, to learn about another example of how something was formed by a giant impact, and maybe learn about our Earth-Moon system from that.
Great. And part of it is you never know what you're going to learn, which is why we explore. And so we always learn something new. We always kept saying what the one thing we expected was the unexpected. And boy,
it was unexpected.
So it's a great thing about exploration.
Yep.
So I saw a nice question here about someone asked about basic, what basic things have you seen? And I thought this might be a good time for me to put up this image, and maybe we could talk about it a little bit. I have the two images.
Okay. Does the mouse work if I use the mouse?
I honestly have no idea.
Okay. The mouse could be used in this.
Yes, so so hopefully everybody is seeing now. I put a picture of Pluto up with the heart on it, and I'm moving my cursor in that picture. I don't know if you can see that. If you can, maybe somebody could type in a comment and tell me if you can see it.
Yes.
Otherwise, we're just going to assume that you can see this happening.
And we can try and describe
you can
it
kind of
verbally
just
as much as
describe it.
possible,
Yeah.
too.
So, well, Kathy's worked on one of the key instruments that delivered this data, so especially
That's
the
right.
color data. So maybe why don't you jump in?
All right, I'll start talking about the color. So one thing
We
is
also
that
have the
this,
color picture next. We can show.
yeah, but this
this
is
is-
actually natural color.
That's natural.
So
color.
this
Right,
is
and-
approximately what your eye would see as best we can analyze and construct if you were on board flying past Pluto.
Right, so the base underlying brightness scale is given by a base map from the Laurie image. It's actually the Laurie image. And then on top of that is layered the color that we get from the Ralph instrument. And the Laurie image scale in this is about 4 kilometers per pixel, whereas on Ralph, for the color images, it was about 28 kilometers per pixel. And so it's the composition of the two gives us the most interesting and most detail that we can get. And we spent a lot of time trying to make natural color that would be what the eye would see. We have 4 color filters. We have a red, a blue, a red, near IR, and a methane filter at 8,900 angstroms. The blue, red, and near IR are relatively broad filters. And so we had to come up with a formalism for constructing natural color, and then we validated that it worked well. And so this is, to the best of our ability, what your eye would see if you were riding on the New Horizons spacecraft approaching Pluto. Do you want to talk about any of the colors, or you want me
Sure,
to?
let's just see, do we have an answer on the cursor?
Cannot see the mouse.
Okay,
Okay.
that's it. Okay, all right. So then we'll just go all descriptive here. So you see what we have been calling the heart as the white region right at the center, and then the dark region off to the left is the head of what we've been calling the whale. And when I look at this, what's astounds me and makes me gasp for air is that boundary between the dark head of the whale, which is full of craters, and the white bright region, which is devoid of craters. You have this sharp contact between what you would immediately interpret as a really old unit on the surface within what you would interpret as a very new or young or resurfaced unit on Pluto. And how you get that and what process is doing that resurfacing at 3 billion miles from the sun at temperatures below 100 Kelvin is just mind-blowing. So
It's probably worthwhile to note too that the dark area, the whale, is right around Pluto's equator. So we're not looking at a pole here for the heart.
That's
It's
Yeah, that's a really good point, Amanda. So the image has been oriented so that the North Pole is pointed up, but it's really tilted out of the page a little bit. And so, yeah, the darker areas are
it's right at the
equatorial.
equator, right?
Yeah.
Yep.
So just historically, for any history fans out there, we've known that Pluto has bright regions and dark regions probably since the 1950s, when people looked at the brightness of Pluto. Even though it's just a fuzzy blob in a telescope, you could tell that it would get brighter and dimmer over the course of 6.4 days. That's how we knew its rotation period. So the fact that we see bright and dark regions isn't a surprise, but it's those sharp boundaries and just the layered and just light, delicate structure between the two is mind-blowing. And so there's going to be atmospheric effects that factor in, and those are things that are so importantly constrained by occultations and the Sophia results. And there's just so much interaction there. It's taken all pieces it's going to take all the pieces of the puzzle to understand what's going on.
So we have a question here. It says, it seems there are really few craters. Is it true? And what does it say on how active is Pluto's geology?
Well, we have to count craters. So there's all sorts of illumination effects, because up near the pole, the sun is up at 51 degrees latitude. So it's really hard to count craters underneath the full light of the sun there. We just don't have the shadow contrast. So that will take other data. I guess the stereo data will help us
That's right.
with that. So it's too early to count craters, though I'm sure people on the internet are already doing it. So stay tuned.
Yeah.
So should we use this opportunity to go to the color, the
Sure.
multicolor
I think that'd be
image?
That'd be
Okay,
great.
so I'm gonna.
This color image doesn't knock your socks off. I know.
So that was very cool. So let me now go to this other one.
Frame ourselves. We're being framed. That's right.
let's see. Okay, here we go. Present to everybody. So, Kathy.
Yeah.
You go first.
I'll go
You're-
first.
you're
I'll go
instrument.
first.
You
I'll go first. Yeah, so this is Ralph data alone. There's no underlying Lori image. And the stretch, it's the same color, it's actually the same individual filtered observations, the same observation that we took that made the natural color we used to make this stretched product. And what we did was we just exaggerated the color significantly. This would not look like the way it looks to your eye, but we want to exaggerate the color differences so that we can learn something about the different units on the surface to see what might be the same color, and that could be some hint of texture or composition. And there's a lot of interesting things here. One of the things that I find fascinating is that the heart you can see is really two very distinct terrains separated by a strong straight line. So
Yeah,
between the
that's
white
just
area and that blue area.
So
Just
maybe we can just say that the obviously Pluto is on the left and Sharon is on
yes.
the right, and then the heart is on Pluto. You can see it in the lower left, maybe at like the 7 o'clock position. But because it's two different colors there, it doesn't look as obvious as it did in the other one.
That's right. It's
Yeah.
not at all obvious that it's a heart anymore. What you're seeing is the left part of it as white and the right part of it as blue, but it's not as distinct at all in this image. And what's interesting, building on what Rick just was saying, was about that sharp delineation between the dark region and the part of the heart. Now we're seeing it bifurcating it right down the middle. So there's a lot of interesting things going on there, and we're going to be getting higher resolution data of this area, and I can't wait to see what it looks like. There's so many different things I could talk about. I'm also interested in that bright area, the very top ridge of it in this exaggerated color. You can see it is a slightly different coloring unit, and you can see that there's some reddish units kind of extruding into, or perhaps we don't know which is going in which direction, or if it's layering over top of each other, but you can see a little bit of the red going into that white or lighter region. And so I'm very curious about details of what's going on there.
I'll say the next step is we have another spectral instrument on the spacecraft called LISA, which this is just 3 color bands, and that has
256
color bands into the near infrared, which is very diagnostic for the methane and other absorption bands. And so we're really interested to see what those LISA pixels, as they're painted across the surface of Pluto, what it tells us about all those different units, at least to the eye, and in color, at least visible color, appear like different things. And we'll see whether compositionally they turn out to be different, or they're just other darker things called tholins, these complex organics that tend to redden and darken planetary surfaces, especially in the outer solar system.
I have a question here in email. He says, how real is the reddish color in the images of Pluto? What is it from, and why don't we see it on camera?
Well, yes.
Those are some nice questions.
Those are good.
We would love to know the
we have
answers.
those questions.
All right, I can,
Yeah, go for it.
so
How
so the reddish color you're seeing here, so, okay, I think they mean in the natural color.
In the natural
Because in
color.
the natural color, Pluto appears more red. And actually, Rick, I don't know if you remember this, but when I was a student at MIT, I was defending my thesis, and
you passed?
And Dr. Binzel was on my committee, and he, in fact, asked me why Pluto was red. So we knew eons ago
Very good.
that Pluto was red, and you could see it from the ground, and that Karen was more neutral color. And so the answer I gave him then, and the one
Must
that
have
we
worked.
still believe, is that we believe that you get methanes and hydrocarbons, and they get irradiated by UV radiation or cosmic rays, and they form these long chain hydrocarbons that we call tholins. There's many different ways to make tholins at different temperatures and pressures. It's not a specific molecule, but it's just representing this sort of large, long chain complex molecule. And these molecules appear dark and reddish in color.
Very
Did I
good.
pass?
Yeah.
Yes,
The ink is still dry.
Now, are we going to get similar color information from the other side of Pluto?
What we have is what we have, or unless
Well,
there's something in the can.
there's a number of data sets that are on the spacecraft. And so we took, when we were looking at those other geometries, we were taking color images a couple of times a day, and right around the Karen side of Pluto, which is not this side, this is the anti-Karen side, we were taking up to about 3 color images a day to really concentrate and get more information. So that data is on the spacecraft. It won't have the same resolution as this, but we did the best we could at the velocities we were flying through the system.
Yes. Fundamentally, Pluto limits us because it's a slow rotator, 6.4 days. So just by that physical fact, there's always a side that you last saw 3.2 days ago.
Okay, so we're getting close to 4:30, and I actually have no idea if Google Hangout is going to toss us off or not. So if
but I want to give a shout out to the Sophia occultation and to everything that Mike put into it for getting the spacecraft or the airplane to go where it needed to go. Amanda getting the prediction, get in there. Yay, get the stars in here. And Amanda getting the prediction at the last, updated last minute. Mike for believing Amanda.
Thank you.
To put the airplane in the right place because they absolutely nailed it. It's already public knowledge. They have the central flash.
It is.
And you only get that if you really nail it and put yourself exactly in the right spot at the right time.
And together with, this is very complementary to the New Horizons data that we have.
Absolutely. And I have to say, and Kathy can support it, when the news came to the New Horizons team that the Sophia occultation was successful, they had the central flash, the team erupted.
The team did. We were so excited for you guys. Leslie was literally jumping up and down.
Oh, yeah. No, it was prior to today, it was the biggest eruption of joy and everything. So anyway, I want to try to socialize that you guys are here. I'm not sure, everyone has sort of seen
Put
you
two
and
and two together.
realize that you guys are here and that you're the celebrities that you are. And so we can try to socialize that a little bit throughout the rest of the day. It's been too hectic.
There's just too much going on.
We've been running around like crazy all day, but it's been great fun.
It has been. So I think we're going to stop it there, and I thank everybody for joining into this Google Hangout and asking the great questions. And we will see you back on campus at some point.
All right. Yay, Pluto.
Yay, Pluto.